In the students, this we're going to be going over two examples and how to apply some of the basic differentiation rules, the power, sum and difference, constant, product, and quotient rules. Okay, so before we take a look at the examples, let's take a look at the rules real quick. We have the power rule. So for the power rule, we know that the derivative d dx of x to the n is basically you power down the power, whatever the exponent is, times x to the n minus 1, and you reduce the degree by 1, or you subtract 1 from the degree. Okay? So you power down the power, and then subtract 1 from the power that was there before, that you power down. Alright, so there goes your power rule. You also have the sum and difference rule. The sum and difference rule basically tells us that you can distribute the differentiation across the sum and product of terms of a function. Okay, so d dx, let's see, two functions, u plus or minus v, is equal to the derivative of u. We can write that as d dx of u plus or minus the derivative of v. Alright, so there goes your sum and difference rules. And then you also have your constant rule. Alright, constant rule is very intuitive. Um, it tells you that when you are differentiating a constant multiplied by a function, d dx of u, d dx of c times a system function u of x, you can factor out the constant from the derivative and focus on differentiating the function because this constant doesn't change. This is what you're taking the differentiation of, or the derivative of. Okay? So that goes your constant rule. And then you also have the product rule, which applies to the product of two functions. So the derivative, d dx, of the product of two functions, let's say u and v, is equal to v u prime, the second function times the derivative of the first, plus plus u v prime. Okay? Plus u v prime. In some textbooks, it's written as u v prime plus v u prime, but you know that addition commutes, so it doesn't really matter the way that you write it. All right, so that goes your product rule. And then your quotient rule, if you have the derivative dx of the quotient of two functions, u over v, is going to be v u prime minus u v prime. Similar to this, but you just switch the plus with a minus. The whole thing divided by v squared. Okay? So there goes the derivative of the function. Some people normally use the mnemonic device low and high, so they say if you want to find the derivative d dx of high over low, so basically the function on the numerator is your high and the function on the denominator is your low, is basically the low, I'm sorry, is a high, is low times d high minus high times d low divided by low squared. Alright, so low d high minus high d low over low squared is the quotient rule. So if you use this mnemonic device, I don't know how it's helpful, but some people like it anyway. So there goes one common mnemonic device for remembering the quotient rule. So how I remember it is I just switch the plus in the product rule in this form with minus and then divided by b squared, and there you have it. Okay, let's go ahead and try out some examples. Example number one. Example one. The task is to find the velocity function if s of t is equal to 3t squared minus 2t. Okay, so the question is, what's the relationship between velocity and position? All right, so there's a continuum I normally use to help remember how they connect, and it's the S V A J continuum. All right, so this is position, velocity, acceleration, and jerk. If you're going from the top to the bottom in this continuum, from one function to the other, what you do is you differentiate. Okay, you're going to find dt. All right, so if you want to go from the position to the velocity, you take the first derivative. From velocity to the acceleration, you take a derivative. And then from acceleration to the jerk, you take a derivative, okay? So let's go ahead and illustrate how these things connect. So the velocity, you have to take a step down from position, so is equal to s prime. So the derivative of velocity of position is your velocity, okay? And then acceleration is the derivative of velocity. And then the jerk is the derivative of acceleration. All right, so that's how you find one given the other. So in this problem, we asked to find the velocity function if the position function is 3t squared minus 2t. So let's write out the equation first. V of t, velocity function, is equal to s prime of t. All right, so that's going to basically become 3t squared minus 2t prime. So the derivative of this. So how do we differentiate this? Well, to do this, we're going to use the difference rule here. So the derivative of this term minus the derivative of that term. So we're going to write it as uh, 3t squared prime minus 2t prime. Okay? Now, now that we have it written in now that we've applied the difference rule, we're now going to look at each term. If you notice that the variables in both terms have a coefficient or constant in front, so we're going to apply the constant rule here. So for the first time, if we apply the constant rule, it tells us that we can factor out the constant from the derivative. So this becomes 3 times t squared prime minus, same idea applies here. If we're using the constant rule, we can factor out 2, so it's 2t prime. Okay? Now we can start differentiating. If I apply the power rule to t squared, bring down the constant, we'll bring down the power down the power, and then subtract 1 from the power. So it's going to be times 2t to the 2 minus 1. Okay? Minus 2. Now this variable right here, this t has a power of 1. All right? If I apply the power rule there, I'm going to have times 1 t to the 1 minus 1. All right? All right, so let's go ahead and simplify this. So we're going to have 6 t to the first power minus 2 times 1 is 2, 2t to the 0th power. Okay? Now, if we reduce it, we're going to have 6t minus 2. T to the 0 is just 1, so we're going to be left with 6t minus 2 as our final result. All right, let's box our answer. Well, let's also indicate what this is. This is our velocity function. So let's take a look at this whole procedure again. If you notice, we can do this rather quickly without doing all the steps. If we wanted to apply the power rule directly to this term, I could have multiplied 2 by 3, which makes that 6t minus 1, so we have 6t. And then a trick for differentiating terms with a first degree variable, if a variable has a degree of 1, when you apply the power rule, its power becomes 0 and just basically takes off the degree. It takes off the variable. So in this case, the derivative of 2t is of negative 2t is just negative 2. So let me give you another example. Let's say you wanted to look for 4x prime. This is going to have a derivative. Its power is going to become 0 after you differentiate it. And it powers down 1. So this derivative will simply be 4. Okay? And then let's say you wanted to do 1/2 x. So when you differentiate this, since it has a degree of 1, you can easily see that the derivative of this x is going to be 1, so your final answer is automatically 1/2. So when you have a constant multiplied by a variable in the degree 1, the derivative involves simply eliminating that variable. Okay, so you just drop the variable, and the constant is always the derivative. If you think about the slope, y equals 3x plus 5, how do you find the slope? You just simply take the coefficient of x, which is m. So that is exactly what we're doing. This is the slope of that first degree term, the slope of the tangent line, so that's the degree. So in this case, if you want to differentiate this, your answer will be 3. Okay, so y prime is going to be 3. So a shortcut for differentiating first degree variables again is you just simply take the coefficient of that first degree variable. So there goes your velocity function. All right, let's take a look at example number 2. Take a look at another problem. Example 2. So if, for number 2, if f of x is equal to 3x squared plus 4, and g of x is equal to 2x to the third minus x. The task is to find f times g prime and f over g prime by first expressing the derivative or derivatives uh, in terms of f, g, f prime, and g prime. Okay, so what we're going to do is first of all explicitly apply the formula to this situation using the names of the functions and then proceed to finding the derivatives. Okay, so let's take a look at the first part. All right, let's take a look at that. For the first part, we're going to find f times g prime. So let's review what the product rule is again. So d dx of u plus u times v prime, the derivative of uv is vu prime plus uv prime. Okay, so let's first of all express it using f and g. If we apply that here, the first function is u, and then the second function is v. So this is u, and then this function right here is v. All right, so if I apply the product rule to this situation, what are we going to have? We're going to have g f prime plus f g prime. Okay, you can write it as fg prime plus gf prime since addition commutes, so it doesn't really matter the order. I like to write it like this because it helps me remember the quotient rule. Okay, so now we've done the first part, expressing it in terms of f and g and their derivatives. Now let's actually find the derivative. So g is 2x to the third minus x, as indicated here, times derivative of f, so it's going to be 3x squared plus 4 prime, plus f, which is 3x squared plus 4, times the derivative of g, which is 2x to the third minus x prime. All right, so let's go ahead and evaluate this derivative. So we're going to have 2x to the third minus x. Now we're going to apply the sum rule here. Okay, so how do you apply the sum rule here? We're going to differentiate 3x squared first. So let's write this down. This is going to be 3x squared prime plus 4 prime. So you differentiate this two terms independently, and then we're going to multiply it by this term right here. Okay, so plus 3x squared plus 4. Now, this term right here, we're going to apply the difference rule. So the derivative of difference of terms is equal to the derivative of the individual terms that are being subtracted from each other. So if I apply the difference rule here, it's going to become 2x to the third prime minus x prime. All right, whatever the result is, we'll distribute it with this term right here, okay? Now let's go ahead and evaluate the derivatives, then we'll distribute. So we'll have 2x to the third minus x times the derivative of 3x squared. If you apply the constant rule, you factor out 3. And if you apply the power to x to the second power, it's going to be 3 times, I'm condensing 2 steps, 3 times 2, x to the 2 minus 1, which is just 1. Okay? Now, plus the derivative of a constant. Imagine this as having x to the 0. Okay, so what happens if you have x to the 0? What will the derivative look like? Well, let's go on the side and work that out. So if I had 4x to the 0, and I wanted to find the derivative, it's going to become 4 times, you power down the exponent, so 0, x to the 0 minus 1. We have a 0 here. What would this entire product be? It's going to be equal to 0. So what that tells you is that when you're differentiating constants, there is no rate of change there. The slope is going to be 0 because constants are basically horizontal lines. So the 4 prime is simply going to be 0. Okay, so don't forget, derivative of constants alone is simply 0. Plus, shift our attention here, 3x to the second power plus 4 times. Now, if we apply the constant rule, it gives us the ability to factor out a 2. And if I apply the power rule here, I'll power down the exponent 3 and then reduce the degree by 1. So 3 minus 1, which is 2, minus x prime. X has a derivative of 1. I'm sorry, has a power of 1. So you power down the 1 and then subtract 1 from 1, you get 0. And then you're going to be left with 1. Okay? But remember, we talked about this earlier. If you have a variable with a degree 1, the derivative is always the coefficient. Okay, so imagine that there is a visible 1 right here. So what would that derivative be? Derivative of this will simply be 1. Okay, we see why that's the reason, because if you have x to the 0th power, x to the first power, you power down the 1, and then you have 1 minus 1. X to the 0 is going to be 1. 1 times 1 is 1. All right, so there goes the derivative of the last term. Okay, now let's just go ahead and simplify this. We'll have 2x to the third minus x times 6x plus 3x squared plus 4 times 6x squared minus 1. This one, we just distribute the 6x to these two terms right here, this and that, and then that yields 12x to the fourth minus 6x squared plus, and then we're going to follow this out first, outer, inner, last. So when we do the first, we'll have 18x to the fourth minus 3x squared plus 24x to the second power minus 4. Okay, so we can go ahead and combine like terms. We can combine, let's see what we can combine here. 12x to the fourth and 18x to the fourth can be combined to give you 30x to the fourth. And then negative 6x squared minus 3x squared is negative 9x squared, plus 24 is plus 15x to the second power. So plus 15x squared. And then last but not the least, we have minus 4. Okay, so bring that down, minus 4. And this represents f times g prime. Okay, the derivative of the product of the two functions. All right, now we're going to go ahead and find the derivative of the quotient of the two functions, f over g prime. So what we're going to do is we're going to first of all apply the quotient rule. Okay, so what is the quotient rule? Let's refresh our memory about what it is. So the derivative, d dx of u over v is equal to v u prime. Remember, low d high, you start with the low. V u prime minus u v prime divided by v squared. V squared. Okay, so let's apply that here. The numerator function is our u, and then the denominator is v. Okay, so if I apply the quotient rule to these two functions here, we're going to have g f prime minus f g prime divided by g squared. Okay, so this is expressing the derivative of the quotient of these two functions using g, f, and their derivatives. Now let's apply it to the function, the actual problem that we're dealing with. So g is 2x to the third minus x times f prime. So what is f? Let's write down what f is. F is 3x squared plus 4 prime minus f, which is 3x squared plus 4 times g prime. We know that g is 2x to the third minus x, that prime. This entire expression divided by g squared. So what is g? G is 2x to the third minus x squared. Okay? All right, now let's go ahead and differentiate it. I'm going to be skipping steps here. So we have 2x to the third minus x. If I apply the difference rule here, I have to differentiate this individually, okay? Now if I apply the constant rule here, that means I can factor out the 3. Now if I apply the power rule to this x squared, I have to power down this 2, but there was a 3 there before, so that becomes 6x. Now this power 2 decreases by 1, so it becomes 6x. If I differentiate 4 is a constant, the derivative of constants is 0 because there's no rate of change with them. So this goes away, and we just left with 6x, 4f g prime. All right, minus. Now let's differentiate this g. So we have 3x squared. You write on f first, plus 4. And then now let's differentiate this part. 2x to the third. If I apply the constant rule, I can factor out 2. Constant multiple rule, I can factor out 2. If I differentiate x to the third, I power down the 3, multiply by 2. I have 6x. The power decreases by 1, so 6x squared minus. Remember the trick I told you earlier? If the degree of the variable is 1, as represented here, the derivative is simply the coefficient. The coefficient of x to the first power is just 1. So the derivative of 1 of x to the first power is simply 1. Okay? So there goes the derivative. All right, now let's we're going to write the denominator 2x to the third minus x squared. We're going to differentiate, I'm sorry, we're going to distribute the numerator and then combine like terms, all right? So if I distribute 6x to these two terms, it's distributed like that. We're going to have 12 x to the fourth minus 6x squared minus parentheses. Now we're going to distribute this first out of inner last. So we'll have 18 x to the fourth minus 3x squared minus 24x squared minus 4. All right. All right. This is a positive right here. Okay, so 4 positive 4 times 6x squared is positive 24x squared. Okay, so there you have it. Divided by 2x to the third minus x quantity squared. Okay? Now I'm going to distribute this minus to all these terms. It's just going to invert their signs. So let's see what we have. We have 12x to the fourth minus 6x squared minus 18x to the fourth. We can combine these two while we add it. So if I combine these two together, if I combine these two, what do I get? If I combine these two, I get 21x squared, right? Because minus 3 plus 24 is positive 21. And if I multiply by this negative, I will have negative 21x squared. And then minus times this 4 right here, I'll have a plus 4. Okay, that entire expression divided by 2x to the third minus x quantity squared. Okay, now let's combine like terms. In the numerator, if I combine positive 12x to the fourth and negative 18x to the fourth, I'm going to have negative 6x to the fourth. And then if I combine negative 6x squared and negative 21x squared, if I combine those two, I'm going to have negative 27x squared. plus 4, and that entire expression divided by uh, divided by 2x to the third minus x quantity squared. Okay, so this is what our derivative f over g prime is. This book's our answer. So there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel. You can comment to let me know what you think about this clip. Please click like if you liked it, and do feel free to share it with your friends via your individual social networking program. More videos coming from mathgotserved.com/calculus.